Hello and welcome to the third part of this loop series. We're going to be talking about for loops part 2, and we're going to be talking about nested for loops and matrices. Woohoo! In actuality, it is pretty fun. It can get complicated, but it is pretty fun and very useful in games. I mean, think about tic-tac-toe. It's like a 3x3 grid. Or any other board game, like there's like a grid of like scores. Like for example, you might have heard of Minefield. That's a grid too, and that's basically what a matrix is. It's a grid. So we have a matrix right here, or a two-dimensional list called board game. Now you can think of it as a list of lists. That's kind of hard to say, but basically we have a list containing 5 lists, and each of those lists contain 5 elements called that are basically 0. So we have a square. Now, what we're going to do is we're going to go over these certain scenarios and try to use nested for loops, and I'll show you what that is, to solve these scenarios. So yeah, let's get right into it. Before we do that, right here, you have to add a doc string, which I forgot. So let's add one right here. Basically what this does, prints out the board in a nice, clean way. Don't worry about this code too much. You might not understand it now, but maybe later on in the video when I show you what nested for loops are. It's basically a for loop inside of a for loop. Maybe try to see if you understand what's going on here. But this is just to print out a nice board so we can see if we did it correctly or not. So scenario 1. The first row wins $10 and the second column loses $10. So we want this row, the entirety of it, to gain 10, and we want this column right here, we want it, no, I can't highlight that, we want it to lose 10. So let's get started with this. For R in range, so R stands for row, for R in range, length board game, right? And this is a square, right? We know it's going to be a square. We don't know if it's 5 by 5. It might not be 5 by 5, but we know for a fact it's a square, okay? And with that knowledge, I'll show you what we can do. For C in range, len board game, because we know it's going to be the same. Now let's say if it wasn't the same, how would we find the length of the columns? So right now it's 5. Let's say we added another 0 to each one of these things. So now we have a 5 by 6 grid. Well, all we have to do is we have to say board game 0. So we'll just get the length of this first list, which is 6. And that's basically the case for all of these lists. Now, matrices will always have, each list will always have the same length. So this will have 6, and then this will have 6, and so on. It won't be the case where this one has 7 and this one has like 4. Then it won't be considered a matrix. Okay? So that makes your life a bit easier. Okay, so now we need to make the first row plus 10. So let's do that. If R is equal to 0, because that's the first row, right? Then we make board game RC plus equal to 10. Increase the score by 10. And if the column is 1, meaning if it's the second column, if the C index is 1, we can make board game RC minus equal to 10. So this is how you access an element of a matrix. You first have the bracket, one square brackets, and you say R, which represents which row it is, right? Is it this row or is it this row? And then you have C, which represents which index is the column at. So is it this number, is it that number, is it that number of the first row, right? Finally, let's see if the board game looks correct or not. Print board game. Let's run this. Oh, my bad. I forgot the parentheses. Looks good. So we have 10, 10, 10, 10, 10, right? Then we have negative 10, negative 10, except for the first one. So the first one, remember, what our scenario was that we want the first row to win $10 and the second column to lose $10. So instead of elif, we need to put if here. And sometimes this might pop up when you're looping. You need to just change a few tiny things. And it gets really annoying and it turns most novice programmers off. But just persevere through it and you can make a good board game like this. And this looks very simple, but you can do a lot more with it, trust me. This might even be the basis of a cool game that you make. I just use it as an example. And you can make a battleship, tic-tac-toe, minefield, any sort of 2D game. Okay, now let's do a more complex scenario. The player in the middle was hit with an asteroid. Oh no. Suddenly they get $10, suddenly they get hit by an asteroid. How lucky or unlucky. They now are dead, of course, and are replaced with an X, along with any player directly surrounding him. So what this means is that right here, this 3x3 grid in the middle, basically, is all dead. So first we have to get the index of the middle guy, and we know this is a square. Remember I said keep this in mind. And therefore we know that the index will be the same in the row and the column. So middle square index, right? And that's what I'm going to call it, but I'm going to short form it down to MSI. And in your code, you should add a comment indicating what MSI means, but I don't want to write this out a lot because we are going to be writing this out a lot. So MSI stands for middle square index. And to get that, we're going to take the length of the board and we're going to divide it by 2. Now, what does this double divide sign mean? Just to refresh your memory. So a single divide sign would return 2.5. 5 divided by 2 is 2.5, obviously. But the double divide sign always rounds down. So 5 double divide sign 2 is going to equal 2. And this is helpful because that's the index. Because remember, we're going, the row is 2, 0, 1, 2, and the column is 2, 0, 1, and 2 right here. Okay, so that's going to be our middle square index. Now let's write our nested for loop. I can just copy this honestly. Okay, so I copied that, and now let's come up with our for loop. So we know, so the way to go about this is that first of all, we know that this middle square index is dead, but we also know that any row to the left or right of it is also dead, and that any column to the bottom and top of it is also dead, right? So we know that row -1 and row +1 is dead, as well as only if the column above it or the column below it is dead. So how do we get this range? That's a hint. Range is not just used in for loops. So let's talk about that. If R in range MSI -1, MSI +2, and C in the same range, because remember this is a square, it's very helpful. Okay, let me copy that. Great. Then we replace that with an X or capital X, because you know, yeah. Anyways, let's talk about why this works. So range MSI -1, so the row behind it, right? MSI +2. Remember, the range function automatically subtracts 1 from this, so this is technically, like in human speak, if it's below the middle index by 1, or if it's above the middle index by 1. So if it's equal to 1, 2, or 3, as well as the column if it's equal to 1, 2, 3. So we can have this one, right, which is both the row is less 1 and the column is less 1. And then we can have this one, which is the column is greater by 1 and the row is greater by 1, and anything in that box radius. And this is really helpful for getting like cross sections of your grid. Let's say we want this cross section, right? We have to pinpoint this index right here, and we'll basically do the same thing. Let's say we want a bigger cross section. Let's say we want the entire grid, then we basically increase the range. And this could be very helpful in your board games, especially maybe even Minefield or something like that. So let's see if this works. There might be a few errors. Let's try to fix them up if there is any. Okay, so the error that we're having and the reason why this is not working is because I did double equals instead of single equals. Woohoo! So as you can see, even people like me can overlook these small mistakes while I'm typing fast. So let's see. Now it looks good. The people here died by a meteor. People up here are doing pretty well, and there's that one random -10 down there. Okay, I hope this piqued your interest. This is very challenging, and it's a nice puzzle to solve once in a while. I have a few of these puzzles in the source code down below in the description, but if you do want puzzles like this, we have a decent amount of them that we can give to you. And yeah, that's it for this video. I hope you guys enjoyed. Next up, you guys are going to be watching the project video on rock, paper, scissors, or more, depending on if we might make more videos. And then after that, you can continue on to the advanced portion of our Python curriculum, which is writing and reading from files and classes. See you guys later. Bye.